Okay, our third speaker is Arturo Nunez. He's been working at the Gemini Observatory for nearly 14 years, and he's been supporting software operations in many capacities, including real-time instrumentation, high-level software engineering positions. And since 2011, he's been the head of the software department at the observatory in a very, very beautiful place. So, welcome, Arturo.
All right. Thank you. These are the two cars that we will be talking about now. So the Gemini Observatory has two telescopes. They are identical telescope, 8-meter diameter, each one optimized for infrared optical observations. They are located in Mauna Kea in Hawaii. The other one is in Chile. They are used every night for observation. We observe remotely, meaning that during the night there is no people at the summit helping with the observations themselves. So in order to do that, we do have control systems. And what I want to talk about is some upgrades that we are doing to them. So let's look inside. So this is an overview of the control systems at the observatory. I'm not going to go into the details of each of these, but just to give you an idea, we have 3 adaptive optics systems, 12 telescope control systems, 4 instruments, and 1 data handling system. And all of this is multiplied by 2 because we have 2 sites to support. So why we decided to start this upgrade? It's because of this. So we have this document. This document describes how all the control systems at Gemini should be implemented. And it's great. This is a great document to have. But there is only one problem with it, which is that. It says that the last modification and update was done in 2001. And so that's not good. In that document, we decided to use VxWorks as our standard operating system for all the control systems. You see the same pattern in here. The version that we are running is from 1999. We use APEX as our standard framework for control systems. If you look inside our observatory, these are all the versions of APEX that we are running. This morning we were hearing about APEX 7, and you can see here we are way behind from there. This is CAPFAS, one of the tools that we decided to use for database development in APEX. Nobody likes this tool anymore. Everybody hates it, actually. If you look inside the APEX webpage, you find stuff like this in reference to tools that are supposed to support you in doing CAPFAS development. So we decided to do something about this. After some feasibility studies, we decided to change VxWorks and replace it with RTEMS. We had another paper in an SPA a few years ago talking about the reasoning behind that. The upgrades also we decided to take APEX and unify the version that we are using there, using just one stable common version to all the control systems. In addition, we figure we will update all the libraries that we are using and try to rationalize the software inside. Also, the CAPFAS tool, we decided to make a change and use something that is better. So we took a tool produced by Triumph called TDCT. We have gotten really good support from them. And finally, we decided to start with the telescope control system, which is the heart of the observatory control software. So with that in mind, we defined this strategy to do these upgrades. So the first step in the strategy is to improve the way we do software by upgrading our application development environment. So that was the first step. With that, we were going to rationalize the software, coming up with a new common code base. I'm going to go into some details of that in a second. And finally, do the actual upgrades of the control systems. And in the process, we decided to update the standards, such as we don't get into the same situation and we can sustain the observatory in the next years. So let's look inside the application development environment first. So the application development environment consists of all the operating systems, development tools, support packages, build environments, and configuration control that are used to develop software at the observatory. So we wanted to standardize that. But in addition, we wanted to come up with a standard process to do that work, such as we can actually follow the same rules all over and over. So for this, we face the question of how do we do this? This sounds like a problem that has been solved before. So instead of doing it by ourselves, we team up with experts. So we work with observatory science for them to help us understand what others are doing and how this problem has been solved in other facilities. So we identified that the system that is currently used, or was used back then by Diamond, was really close to what we needed. So observatory science helped us to adapt the system that is used to develop software and deploy the software to operations by Diamond, and they brought all the tools that we really wanted to have in our new development environment. So that worked really well. So this is an overview of our application development environment. So from the start of a new development all the way down to making it available to operations. It comes with a set of Python scripts. You can see some of the scripts inside the boxes there that are really helpful to maintain the process and help you to just stick to the rules, basically. So we're really happy with this. So I think recommendation from this part of the work for us is it was really useful for us to have a common development framework and a process that supports it. We should pick current and well-supported software tools. We shouldn't reinvent the wheel, and definitely use experts, because they really allow us to, they brought us perspective, and they allow us to focus on things. So with the application development environment completed, this got finished in 2014. We started to use it in 2015. We started to work on our common code base. So what did we do here? In this case, what we did was to look inside each one of the control systems that we wanted to operate and try to understand what was inside them. So with that, we look at commonalities among all the systems, and we started to update all the modules that have been evolved inside each of them. Then we move copies of those modules into libraries. And finally, we decided to minimize the amount of customization, such as each one of the control systems could use a really, really simple and the same module all over the different control systems. So with that, we ended up with a collection of drivers, a collection of libraries, and important, we also end up with test plans, which allow us to basically verify that the functionality provided by each one of these libraries was correct. One of the problems that we found while doing this is that we forgot the hardware part. We were focused on software, and in some cases we ended up with all the software for drivers, for instance, completed, and we didn't have the hardware for testing it in our lab. We had it in the telescope, but that wasn't good. So we had to cope with that problem. So on this aspect of the work, I think the important aspects that we learned is that we should analyze our situation first before trying to rationalize anything. We need to consolidate and merge libraries and modules. We need to manage customization, try to minimize it. We have to plan for hardware inventory for testing. Having a consistent set of requirements, and especially test plan, was really useful because it will allow us to keep these modules current. So with that, we started the actual upgrade. So this is a work that we started mid-2016. It's been like 9 months since we started. So the first question was, how do we start this work? This is a view of all the telescope control systems that we wanted to upgrade. We figured we would start with the simplest thing. So the first thing was, how do we define simple? So we invented it. We invented a way of our complexity factor. And that complexity factor was defined as the number of dependencies against the common code base. So with that, we came up with systems that we declared easy and systems that were harder. And we focused first on the simple systems to do the upgrade. So the next question is, how are we going to test this? So the first approach was, okay, let's use simulation. We just heard a talk about all the simulation aspect that you can do in order to test your systems. So we were going to use our design documents, trying to come up with simulation models and test plans. But unfortunately, in our case, we discovered that the design documents were also obsolete. So they were useless. So we abandoned that idea, and instead of doing that, we decided to interview all the users of the systems. By users, I mean maintenance staff, operators, software engineers doing support, and come up with use cases. Based on those use cases, we extracted requirements, and based on those requirements, we came up with our test plans. So in order that once we had those test plans, we started the work of porting, then testing the software in our lab as much as we can, and then we started to test the systems at the telescopes. And of course, many problems were found, and we were like, trying to debug and try to resolve these issues. And eventually, those problems got resolved, and we were ready to put the systems in operations. So right now, as of last week, actually, we finished implementing in operations all the easy systems, being the mount control systems, the last one that we did. And we are in the process of coming up with test plans of the systems that are shown in that diagram. So this is in really good shape. So things that we have learned is that starting with simple things is good. It helps you to get some courage to do this work. Having comprehensive test plans and procedures is really useful. One thing that we learned is that it was easy through this process of interviewing people to focus on functional requirements, and performance was something that we kind of overlooked, so we had to pay special attention to make sure that those were accounted. Communicate your plans and make sure that everybody is aware of those, and have contingency plans in case something goes back, as we heard in previous talk. So future work, we plan to complete this work by April 2018. Our standards are planned to be completed by the second quarter of the next year. And then we plan to launch future upgrades that will involve more hardware aspects of the telescope. So I think the conclusions is be brave. Things can be better. Use experts, definitely. Don't try to do it all by yourself. Focus on simple things first. Create comprehensive test plans. Communicate those plans, and update your standards so you can actually maintain this work in the future. And finally, I think we should include obsolescence management right off the bat. We should start with that, and we should not wait until your parts are starting to be sold on eBay before you start thinking about these things. So with that, I want to thank you. That's my name and contact information if you want to get more details. And that's my team that actually did all the work. So thank you.
Quick question, how do you measure the code dependencies between the different components?
We did, there was an analysis that we did on all the systems. So that was a document that we generated. It was over 100 pages, where we identify all these dependencies among all the different modules and try to rationalize them and try to minimize those. So that's what we did. It took like 6 months, actually, to do that work. So that's the way we managed that.
Because of behavior differences between the two operating systems.
Yeah, that's good. So we use, so APEX has a layer of support called OSI, which allows you to make you independent of the operating system. So we move into that. But even though that promised to be like really easy, it wasn't. We found a few issues. Especially, for instance, one of the things that comes to mind is when the way BXWorks manage memory in comparison to ARTEMS. So we had to come up with new libraries to support different aspects of these changes. So again, we rely on contractors. So for instance, there was one problem that we ran into trying to move memory among different aspects of our systems, and that library didn't work for us in ARTEMS. So we work with Osprey, and they come up with a new layer of software for us, and we use those things to replace those calls. So we have to pay attention to every specific operating system call, basically. So semaphores and mutexes and anything that has to do intercommunication process, that kind of stuff needs to be looked at. But it wasn't too bad, to be honest. So there were a few things that actually required more work, but I would say 85% of the work was transparent from VxWorks to Artems.
Okay, I'd like to thank Arturo again.
Thank you.